Hello and good morning to everyone. We are from the group Ubuntu from Paxil 1213 operating system. I am the leader, Lakaneshwara. My matrix ID is B12510095 and I will be presenting the group network topology demo. Our group members are Lopsihin,
Kamali,
Chasenki. In this demo, we will show our private virtual network configuration using the Oracle VirtualBox with two Debian Linux virtual machines, which is a server and a client. Okay, right now we're going to show the hosting that we set up on the server and a client VM that we set up it during the lab setup. So this is the virtual machine for the server. As you can see now, right now, if I write host name, it will show OS class, and if I goes to client, alright, host name, it will show OS class too, because both of the machine we only set it up as OS class, we didn't change it to a different name. Okay, now I will show the server IP address. On the server VM, I'm going to type IPA. As you can see, there are two network interfaces. The first is EMP0S3. This is the net adapter for internet access. And the second is EMP0S8. This is the internet network adapter. And you also can see that the EMP0S8 has the static IP address 192.168.1.254 with subnet mask 255.255.255.0, which matches our network topology design. Okay, right now I'm going to explain the difference between the static IP and the dynamic IP. It is very important in our network design. A static IP address is manually configured and does not change. It stays the same every time the machine boots. In our project, the server has a static IP of 192.168.1.254 on the internal network. This is important because the client needs to always find the server at the same address to use DHCP, SFTP, web, and database services. The dynamic IP address is automatically assigned by a DHCP server and can change. In our project, the client VM received a dynamic IP address in the range 192.168.1.5 to 192.168.1.10. The address are automatically assigned by our DHCP server running on the server VM. We can see this on the client. So right now, I'm going to go to the client server. As you see, if I type IPA show ENP0S3, you will able to see the client's DHCP assigned IP. The IP address that the client received is 192.168.1.5. Notice the word dynamic and no prefix root in the output, which confirms this was assigned dynamically by DHCP, not manually configured. And now I'm going to show you the server internet access. I'm going to head back to the server VM, and now I'm going to show you the server internet access. As you can see, the server successfully pings the 8.8.8 IP address with 0% packet loss. This proves the server has internet access through the net adapter, which was set during the adapter 1. Notice the IP address being written. These are the actual servers confirming real internet connectivity. Okay, right now I'm going to head to client VM to test the internet also. As expected, it shows that 100% packet loss, which means that the client does not have the internet access. This is intentional and matches our network topology. The client only has access to the internal network to communicate with the server. It cannot access the internet directly, which is a common security design in corporate networks. Right now on the client VM, I'm going to ping the server from client. As you can see, the client can successfully reach the server at 192.168.1.254 with 0% packet loss. This confirms our internal network is working properly. And if I goes to the server and I ping the client from the server, as you also can see that the server can reach the client as well. Both VMs can communicate with each other through the internal network. That concludes our group network topology demo. To summarize, our network consists of a Windows host running 2 Debian Linux VM in a VirtualBox. The server has a static IP of 192.168.1.254 and provides services to the client. The client receives a dynamic IP from our DHCP server. The server has internet access via NAT, while the client is restricted to the internal network only. Each group member will now individually demonstrate their assigned service. Thank you.
Okay, good morning. My name is Lok Zihin. My matrix number is 1525100033. I'm member 2 of group Ubuntu. So my task is to configure the DHCP server for our PXU123 operating system mini project. In this presentation, I will explain what DHCP is, show the configuration, demonstrate the service
DHCP stands for Dynamic Host. DHCP stands for Dynamic Host Configuration Protocol. So it's a network protocol
that automatically assign IP address and other network settings
to the device of the network. Without DHCP, a network administrator would need to manually configure the IP address on every device,
which is time-consuming and error-prone. With DHCP,
when a device connects to the network, it automatically receives an IP address, subnet mask, default gateway, and DNS server from the DHCP server. DHCP works using a process called DORA, which stands for Discover, Offer, Request, and Acknowledge.
First, the client broadcasts a discover message to find DHCP servers. The servers responds with an offer containing an available IP address. The client sends a request to accept the offer, and finally, the server sends an acknowledge to confirm that the assignment. The IP address is then leased to the client for a set duration called the lease time.
In our project, the DHCP service is installed in the server VM and configured to assign IP address in the range 192.168.1.5 to 192.168 to 1.10 to client on the internal network. Okay. So you can see the ISC DHCP server service is running and active, and it shows in green. This tells us the DHCP service is currently operating and ready to assign IP address to clients. Okay, so now I'm showing the DHCP configuration. So here's the DHCP configuration file. So you can see the subnet block for 192.168.1.0 with net mask 255.255.255.0. So the range is set from 192.168.1.5 to 192.168.1.10, meaning only IPs in this range will be assigned to clients. So the router option is set to 192.168.1.254, which is the server's IP. The lease time is 600 seconds by default. So now I'm going to show the interface binding. Here you can see the interface v4 is set up to ENP0S8. So this is an internal network interface. So this means the DHCP servers only listen for requests on the internal network adapters, not in the internet-facing adapters. So now we are going to switch to the client VM, and we are going to show the testing at client and correct IP. So switching to the client VM, you can see the client has received IP address 192.168.1.5 with subnet 24. So this IP is within the range we configured 192.168.1.5 to 192.168.1.10. The word dynamic in the output confirms this IP was assigned automatically by our DHCP server, not configured manually. So this proves the DHCP service is working correctly. So after that, we are going to switch to the Ping server from clients. Okay, so from the clients, I ping the server at 192.168.1.254. So as you can see, we get 0% packet loss. The client and server can communicate through the internal network. So after that, we are going to switch to the server VM. So switching to the server, I ping the client at 192.168.1.5. Also 0% packet loss. Two-way communication is confirmed. So the server can access the internet throughout the NAT adapter with 0% packet loss. So now we are going to switch to client VM. From the client, trying to reach the internet result is 100% packet loss. This is the expected and correct behavior. The client can only communicate within the internal network as per our network topology design. That concludes my DHCP demonstration. To summarize, DHCP automatically assigns IP address using the DORA process. The ISC DHCP server is installed and running on the server VM. The client successfully received IP 192.168.1.5 from our DHCP server. All connectivity tests passed. So that's all for me. Thank you.
Good morning. My name is Kamali Ramachandran. My metric number is B152510116. And I am member 3 of Group Ubuntu. My task is to configure the SFTP server. In this presentation, I will explain what SFTP is, show the server configuration, and demonstrate file upload and download between the client and server. SFTP stands for SSH File Transfer Protocol. Now I will explain about SFTP. SFTP stands for SSH File Transfer Protocol. It is a secure network protocol used to transfer files between computers over a network. SFTP is built on top of SSH secure shell, which means all data transmitted, including the username, password, and file contents, is used fully encrypted. This makes SFTP much more secure than regular FTP. Next, the key difference. The key difference between FTP and SFTP is security. Regular FTP transmits data in plain text, meaning anyone on the network can intercept and read the credentials and files. SFTP uses SSH encryption, so all data is protected. SFTP also operates on port 22, which is the standard SSH port, while FTP uses ports 20 and 21. In our project, SFTP is implemented using OpenSSH, which is already included in Debian Linux. We created a dedicated user called Ubuntu with restricted access using a root directory, which confines them to only their home directory for security. Now I will show service configuration and running status in server. The SSH service is active and running. Since SFTP is part of OpenSSH, this confirms our SFTP server is ready to accept connections. Next, I will show the SFTP user. Here you can see the Ubuntu user was created with home directory at /home/Ubuntu. This is the dedicated SFTP user. Here is the SFTP specific configuration we added to the sshconfig file. The match user Ubuntu block applies these rules only to the Ubuntu user. Root directory restrict them to home Ubuntu only. They cannot access on any other part of the file system. Pause command internal SFTP means this user can only use SFTP. They cannot open a regular SSH shell. This is an important security measure. Next step is I will show directory structure. You can see the home/Ubuntu directory is owned by the root. This is required for root security. The upload subdirectory is owned by the Ubuntu user, which is where files can be uploaded. Now I will show the upload part, which is create a test file on client. Switching to the client VM, I have created a test file called testfile.txt with some content. Now I will connect to the SFTP server and upload this file. I have connected to the SFTP server at 192.168.1.254 using the Ubuntu user. After entering the password, I get the SFTP prompt. This confirms the connection is successful. Next, I will upload the file. I use the put command to upload test file to the upload directory on this server. You can see 100% completion. The file has been successfully uploaded from the client to the server. Next, is to verify and download. Using ls upload, I can see test file is now in the upload directory on the server. This confirms the upload was successful. Next, I will download file back to the client. Now I use the get command to download the file from the server back to the client, saving it as downloaded.txt. You can see 100% completion. This demonstrates that SFTP supports both upload and download. Full two-way secure file transfer between the client and server. Next is exit SFTP. I will now close the SFTP connection. That concludes my SFTP demonstration. To summarize, SFTP is a secure file transfer protocol built on SSH that encrypts all data including credentials. The OpenSSH server is installed and running. A dedicated user Ubuntu was created with root directory restriction for security. I successfully connected from the client, uploaded a file, verified it on the server, and downloaded it back. That's all from me. Thank you.
Good morning, everyone. My name is Cha Seng Hee. My metro number is B15251008. I'm the member from Group Ubuntu. So today my task is to figure the web survey using the Aperture tool. In this presentation, I will explain what a survey is and show the Aperture tool configurations, demonstrate and our custom design web page and show it being from the client client VM. Now I will explain web survey. Web survey is software that store and serve web content such as HTML page, image, and file to user over the internet or a local network using the HTTP or HTTPS protocol. So where user type a website address in their browser, so the browser send an HTTP request to the web survey, and the survey respond with the web page content. Aperture 2, also known as Aperture HTTP survey, is one of the most popular open source web survey in the world. It runs on Linux and many other operating systems. Aperture is highly configurable and support many modules for additional functionality. In our project, Aperture 2 is installed on the Debian Survey VM to host a simple custom web page that can be accessed from the client VM. HTTP stands for Hypertext Transfer Protocol and User Port 80. So HTTPS SSL or TLS, encryption and use port 443. In our project, we use HTTP since we are on local internet network. Now I will show the Aperture tool. This is Survey VM. I will show command. Aperture 2 is active and running on the Survey VM. You can see it also enabled, meaning it starts automatically on every board. So the service has been running since we configure it. Now I will show the custom web page design. Here is the custom web page we designed for this project. It is stored at /var/www/html/index.html, which is Aperture default document root. The page has a title, Paxi 1213 mini project, a heading, welcome to our web survey, our group name Ubuntu, and the survey ID address 192.168.1.254. This is our simple web page design. Now I will show the step to show the survey IP. The survey internet IP address is 192.168.1.254. This is the address the client will use to access our web page. Now I will show the web page from client. This is the web page client, and I will access the web page from client using wget. Missing.
问一下，应该会给他们。
This is the web page from client. Switching to the client VM, I use the wget command to send an HTTP request to the survey at 192.168.1.254. You can see the output show connecting to 192.168.1.254 port 80 connected. So HTTP request send 200, okay. The status code 200 means the request was successful. Below that, you can see the HTML content of our custom web page, the title, the welcome heading, our group name, Ubuntu, and the survey IP address. This confirms the Aperture 2 web survey is working correctly and the client can successfully access our web page. Our client VM use a text-based interface without a GUI browser. We use wget as an alternative HTTP client to demonstrate that the web survey responds correctly to HTTP requests. The 200 OK status and the complete HTML content in the output confirm the web survey is fully functional. That concludes my web survey demonstrations. To summarize, Aperture 2 is installed and running on the survey VM with auto start enabled. We design a custom web page at /var/www/html/index.html with our group information. From the client VM, I successfully access the web page using wget and receive a 200 OK response with the correct HTML content. Our simple web page design is working. Thank you.
Hello, good morning, everyone. My name is Nakanesh Warren and my matrix number is B125100095. I am the group leader of Group Ubuntu. My task is to configure the database server using MariaDB. In this presentation, I will explain what a database server is, show our database design including a custom table, demonstrate the MariaDB service running, and show a remote database connection from the client VM. Right now, I'm going to explain the usage of database. A database is an organized collection of structured data stored electronically. A database management system, or DBMS, is software used to create, manage, and query database. MariaDB is an open source relational database management system that is fully compatible with MySQL. It organizes data in tables with rows and columns and uses SQL structured query language to manage and retrieve data. Databases are essential in server environments because they provide centralized data storage that multiple applications or clients can access simultaneously. In our project, MariaDB is installed on the server VM and configured to allow remote connections from the client VM. This simulates a real-world scenario to where client applications connect to a central database server. In our project, we created a database called Ubuntu with a table called students that stores students' names and metric numbers, for instance. The client can remotely connect to this database and run SQL queries. And right now, I will show you the MariaDB is running and the database design. Okay, so I will type out a command to show you the MariaDB service status. We have to begin this first step in the server VM first, and then we can move to client VM. So the next step is I will log into MariaDB and show database. Okay, now I will log into the MariaDB as the root user. Okay, and it will ask for my password. It will ask for the password, which is Ubuntu123. Okay, this message shows that we have successfully entered to the MariaDB database. Okay, now to see the database inside this MariaDB, I just need to type show databases semicolon, and you will see two databases: information schema, which is a built-in system database, and Ubuntu, which is the database we created for this project. And there are some other database inside too, other than these two databases. Okay. Now I use Ubuntu, and it will change the column from none to Ubuntu. Now I will type the show table, and you can see that this is the table in Ubuntu. Selecting the Ubuntu database, you can see the students table that we designed in this project, mini project. Right now, I will show you the table design. By typing in the describe students one line, you will see the database here. This is the design of our student table. It has 3 columns. ID, which is an integer that auto increments and is the primary key. And name, which is a varchar of 50 to store the student name. And metric, which is a varchar of 20 characters to store the metric number. This is our simple table design. Right now, I will show you the table data. Okay, as you can see here, this is the table data. Here is the data in our student table. We have 2 rows, Ali and Siti, which given each other with a specific metric number. This demonstrates our database has been designed and populated with data successfully. Right now, I will exit the MariaDB, typing in the command exit. And you can see the show by, so this proves that they have finally successfully exited the MariaDB. And now I will show you the remote connection configuration. So first, I will show the bind address configuration by typing in bind address /etc /mysql /mariadb dot conf.d /fit server .cnf. Here you can see the bind address is set to 0.0.0. This means MariaDB listens for connections on all network interfaces, not just local hosts. This is necessary for the client VM to connect remotely. By default, it will be 127.0.0.1, which only allows local connection on the same machine. Okay, now I will move to the client VM. I will move to this client VM because I want to show the database connection from client right now. Okay, so to connect to the database remotely from client, I will type in MySQL. You can see ask for the password. Okay, we have successfully entered the MariaDB in the client VM too. Okay, switching to the client VM, I connect to the MariaDB server at 192.168.1.1.254. Switching to the client VM, I connect to the MariaDB server at 192.168.1.254 using the Ubuntu database user. After entering the password, I receive the MariaDB prompt. As you can see, your MariaDB connection ID is 35, followed by a number which is confirmed. This is a live remote connection from the client to the server's database. Okay, now I will query the database from client by typing in use Ubuntu semicolon. As you can see, we're inside Ubuntu now, and we will type in select asterisk from students semicolon, and you can see the table in the client VM too. From the client VM, I can successfully select the Ubuntu database and run a select query on the students table. You can see the same two rows that appear on the server VM, which is RDCT and the same metric number. This confirms that remote database access is fully working. The client has connected to and queried the database hosted on the server VM. So I will exit the MariaDB on the client too. Okay, that concludes my database demonstration. To summarize, MariaDB is installed and running on the server VM. We designed a database called Ubuntu with students table containing ID, name, and metric columns. Sample data was inserted showing 2 students. The bind address was configured to allow the remote connections. A database user Ubuntu was created with remote access permissions. And from the client VM, I have successfully connected remotely and queried the database. As a group leader, I also coordinated overall network setup and compiled the group report. One last thing is that the reason that we are able to download the MariaDB inside the client VM is because we have enabled the net on the adapter 2 for temporary internet access to install the MariaDB on client VM, because client VM is not supposed to have any internet access, but for the installation of MariaDB, we have temporarily set the adapter 2 to net, install it, and then disable the adapter 2 again. So that's how we are able to use the MariaDB on the client. That's all. Thank you.
What happens if the DHCP server is down?
If the DHCP server is down, the new device connecting are unable to receive the IP address automatically. So they may get an automatic private IP address which unable to communicate properly with the device within the network.
Okay. So my second question is, can a device have both dynamic and a static IP at the same time?
No, the static IP and the dynamic IP are unable to run at the same time. So the static IP will ignore the DHCP, while the dynamic server will get the IP address from the DHCP.
Now I get it. Hey Kamali, I have 2 questions about SFTP to ask you. Why is SFTP prefer over email to transferring files?
SFTP is preferred because it can handle large files that email cannot. It is encrypted so files are securely transferred, and it allows direct access to a storage without size limitation.
Can SFTP work without internet access?
Yes, SFTP requires a network connection between two devices. In our project, the client connects to the server using SFTP through the internal network only, without any internet access.
Hey, Chia, I want to ask a question. Can Apache 2 host more than one website?
Yet, Apache 2 is allow multiple websites to host on one server. However, in our project, we only use one website to our demonstration.
So what happened to the web page if you shut down the server VM?
If server VM shut down, clients are not able to access the web page. The browser will show error version of the VM server.
What is the difference between database and a spreadsheet?
A spreadsheet like Excel store data in a simple flat file, and it is meant for one user at a time. The database like MariaDB can handle multiple users simultaneously, supports complex queries like SQL, and it is designed for large-scale data storage and management.
And second question is, what is SQL and why it is used?
SQL stands for Structured Query Language. It is the language used to communicate with database, to create tables, the data, retrieve data, and delete data. In our project, we use the SQL command to create a student table and query it from the client VM.
Oh, I understand now. Thank you.